In this class, we will discuss about the primary constants of the transmission line. Now, as we have already discussed, for any transmission line, you have to consider the transient time effect when your length of the wire is incomparable with the wavelength of the transmission line, right? So, what we are saying is, let's say that this is my parallel wire. Now, if I want to get rid of the transient time effect, what I can do is I can reduce down the length, right? So it means that I can take small pieces of length. Let me divide this as a small segments. So these are nothing but the small segment of it. Let's say that the length of this, the small segment is delta x. So this is what is my delta x, right? If I zoom this part, right, this length, it will be looking like, if I zoom this part, it will look like again a wire, right? Now, for this wire, can I say that high frequency it will have inductance, right? So it will have inductance. As it is a wire, it will have resistance. It will have resistance. Now, as this will look like a two parallel plate capacitor, in between them it will have a capacitance, right? Now, in between these two wires there can be a charge leakages, right? So that will be nothing but that will constitute the conductance. So this would be G, this would be R, this would be L, and this would be C. So what I have done is, I will repeat again, this is nothing but your transmission line. I know that in order to get rid of the transient time effect, what I have done is, I have taken a small segments of transmission line. It means I have divided into small length such that your delta x tends to 0, which is nothing but small piece of wire. If I magnify this small piece of wire like this, what will it look like is nothing but this. As we know that any wire will have resistance, so it is being denoted by resistance. At high frequency, it will have conductance, right? So, it will have inductance, that we have denoted by L. Between two wires, it acts as a two parallel plate capacitor, so we will have something called as capacitance. Between the wires at high frequency, there may be chances of charge leakages, so that constitute the conductance, right? So this is L, R, G and C. These are actually called as the primary constants of the transmission line. Now, what would be the unit of this? The unit of L would be nothing but, the normal unit of L is nothing but inductance is Henry. In this case, as I am talking for a small length, it would be Henry per meter. The unit of capacitance is Farad. So in this case, it would be Farad per meter. The unit for resistance would be nothing but your ohm per meter. The unit of G would be nothing but mho, or I can say that ohm inverse per meter. Why per meter? Because we know, see, when I give you this wire, the resistance of this wire is, let's say that 1 ohm, but we are talking about the small segment. It means if I take the cap, this is the small portion of this wire. Always, whenever the quantity resistance, inductance, capacitance will be always given as a whole, right? But what we are dealing is nothing but the small segment of that, right? The small segment of this is nothing but this. So what would be the resistance of this? It is nothing but whatever is the resistance, the whole thing per unit length, right? So that is nothing but per unit length is nothing but, that is comes out to be per Henry per meter, Farad per meter, ohm per meter and mho per meter. So that would be the unit of a primary constant in case of your transmission lines, right? We'll see more on this in the next videos.